Hi guys, today we're going to talk about exponents. And exponents are the little numbers that you see on top of a number. Okay, so the 2 would be the exponent. All right, so whenever we're dealing with anything with exponents, we always want to think about the base or the exponent. The base is the big number. So in this case, 4 is the base. All right, it's the big number, and 2 is the exponent. Sorry, that's not writing very nicely. All right, 2 is the exponent. The exponent only ever tells us how many times we multiply the base. Okay, so in this case, this would be 4 times 4, which equals 16. So 4 squared equals 16. Now you may have something that looks like this, 4 to the third power. That means I'm multiplying the 4. Still, my base is 4, and I'm multiplying it 3 times. So it would look like this, 4 times 4 times 4. Multiply it 3 times, so 4 times 4 is 16, times 4 is 64. Okay, so that's what we're doing with exponents. So we're always going to be looking at what the base is and what the exponent is and work from there. So let's take a look at some problems where we might do multiplication or division of exponents. And I'm going to use letters instead of numbers just so we can get a feel for what's actually happening. So let's say we have x to the second power, and we want to multiply that times x to the third power. Again, the base here is x, and it's being raised to the second power, which means I'm multiplying x 2 times. So I'm going to write that x times x. Okay, that's what this one stands for, x times x. Then we're going to multiply that times the next one. So this is x to the third power, which means I'm multiplying, let me just make that small. All right, I'm multiplying x, that's my base, and I'm multiplying it 3 times. So in this case, I'm multiplying the x 3 times. Okay, so when I'm doing this, if I'm multiplying x squared times x to the third power, in essence, I have x squared times x to the third power. Now, when you simplify this, remember that when you multiply exponents, if they're all the same, it's just that number. So we multiplied x 1, 2, 3, 4, 5. We multiplied x 5 times. Remember that exponent, again, tells us how many times we're multiplying the base, in this case being x. Okay, so that's how we could break that down and solve that problem. Now, if you wanted to, you could follow the rule, and the rule is when you multiply with the same base, all you do is add the exponents. So x to the 5th power. So if I had x to the 20th power times x to the 50th power, that would be x to the 70th power, because I would just add the exponents. So when we multiply exponents, we add the exponents. Okay? I should write the word multiply because it just looks like a variable here. So when we multiply, okay, we're going to add the exponents. Okay? Now, let's take a look. Let's take a look at division and what division might look like. Division might look like something like this. Let's say x to the 5th power over x to the 2nd power. Again, we want to take a look. We're going to start with the numerator, or what's on top, and the base is x, and the exponent is 5, which means I'm multiplying x 5 times. So it should look like this on top. On the bottom, the base is x, and I'm multiplying it 2 times. And so what I want you to be paying attention to is you can simplify this. So we simplify this because x divided by x, or any number divided by itself, is 1. So this cancels out. And then I could do the next one as well. And that's going to cancel out. And what I'm left with in this division is x multiplied 3 times, right? And remember, they all have the same base, and then multiplied 3 times. So that's what I would use for an exponent. Now, if I'm following the division rule, what you can do for division, as long as they have the same base, which they do, it's both x, you can subtract. So I could have done x to the 5 minus 2 power, and that would give me x to the 3rd power. So when we're talking about division, when we divide, we subtract the exponents. And remember, this is always if they have the same base, okay? This doesn't work if they don't have the same base. All right, now we're going to talk about power to a power. Power to a power looks something like this. Let's do x to the 4th power squared. So we want to think about what our base is, and our base is what's ever in parentheses. So in this case, our base is x to the 4th power, and we're multiplying that twice. So I'm going to rewrite it. So I have x to the 4th power times x to the 4th power, right? Because it's 2 times. We have our base, which is x to the 4th power, multiplied 2 times. Now I can further break that down because I know that x to the 4th power means I'm multiplying x 4 times. Whoops, let's change that. And multiply x 4 times, so it looks like this. And then I multiply that times x to the 4th power again, which again, I'm multiplying that 4 times. And so when I want to simplify this, I'm just going to write it. The base is x, and I'm multiplying it 1, 2, 3, 4, 5, 6, 7, 8 times, and that's my exponent. And so power to a power would look something like this. Now, power to a power, that's when you have, notice I have one base, but the power, this is important right here. I have power to a power right here being raised to another power. Nothing in between them. That's power to a power. And when you have power to a power, you could follow the rule. It's just multiply the powers. Sorry, I don't know why the computer changed that. Multiply the powers. Okay, so in this case, you could do x to the 4 times 2, and you'd get 8. Actually, let's write the base here. Don't want to confuse anybody. The base is still x, and the exponent is 8. And that's how you would do power to a power. Now I'm going to kind of sum it all up by doing one that has multiple things in it. So we'll get rid of all this. And let's say we have 2x squared y to the 4th power over z, and x to the 5th power y. So now I have something that looks like this. I'm always going to start with just the number. So the only number we have is 2. It's in the numerator. It's going to stay in the numerator. Actually, let me throw another x down here. All right. So now I'm going to look in the numerator. There's nothing that can be simplified in the numerator. I don't have 2 of the same variables. But I'm going to look in the denominator, and you'll notice that I have 2 x's. And this is all multiplication. So I'm going to multiply these x's, which means I'm going to add the exponents. So 5 plus 6 is 11. The base is x, and it's being raised to the 11th power. Okay? So I just took care of these 2. I'm actually going to cross them out. All right, when I took care of those, I did x to the 11th power because I'm multiplying them. And so I would get this. And then I still have a y down here. And on top, I still have x squared, y to the 4th power, z. So now I'm going to look, since I only have different variables on top and different on the bottom, now I'm going to look about division. And I'm going to do this. Okay. And if you look at that, you'll notice, first of all, I'm going to put the 2 on the top. You'll notice that if I cancel these out, I have 2 on top and 11 on the bottom, which means I have 9 more on the bottom. So I could keep it 9 on the bottom. Okay. And on these, the next one, I have y. I have 4 on the top. And when there's no exponent on a variable, that's because it's 1. So I have 4 on the top and 1 on the bottom. If I subtract them, I'm left with 3 on top, right? You can see that there's more y's on top than there are on the bottom, right? There's 4. And the x's, it was opposite because there were more x's on the bottom. So that's where the, the overflow would be. So there were 9 more on the bottom. So that's where I would keep the x. With the y, there's 3 more on top. So I would keep it in the numerator on top. So you can see that here. And then the z, there's nothing to be simplified with the z, so we're just going to leave it. And then now I'm going to look at this, and I'm going to see if I have any variable there more than once. And I only have one x, one y, one z, so that can't be simplified anymore. And the number can't be simplified in any way. So that would be the solution to this. If I asked you to simplify, that's how you would simplify exponents.